Hello, it's Cliff here. In this video I'm following on from the introduction video, which was introducing the new range of lathe tool setters. If you stumbled on this video out of sequence, it'll make more sense to you if you watch that introduction video first, because I'm now going to go more deeply into this LTS-E, the lathe tool setter electronic. There's also a couple of videos where I go into the development of this electronic lathe tool setter a few months ago. I'll put links in the description below that go into some of the details of developing the design and testing the prototype. So carrying on from there, the general construction of this lathe tool setter, we'll take the index plate off for this, is hardened, so it's machined out of steel, it's hardened and tempered and then cylindrically and surface ground so that it's very durable, so that you can hold the shank in a chuck without worrying about damaging the shank. And the anvil is hardened and ground tool steel. So there's quite a bit of work in machining that all out, the internals on each side. One side has all the electrics and the other side has the contacts. The contacts should have good long-term reliability because I've used the same materials as the contacts in the Hallmark ITTP touch probe, which has shown to have very good long-term reliability. So the basic construction is that the anvil moves and breaks the contacts on a touch event, both in the Z and the X. So the anvil swings, and so that once the contacts have broken, there's quite a bit of travel, retraction before you run out of travel. So you can over travel in both the X and the Z quite a long way, several millimeters, before you would run up against a stop and start to damage, for example, your tool and so on. While I'm on the basic construction, it's cylindrically ground between centers, between here and here, and the whole body, the shank and the corners of this part of the body are all ground in the one setting. So that represents a long parallel cylinder, and so you can run a dial indicator on these corners, which is the same concentricity and straightness as the whole outside of the body, and you can check that your collet or chuck is holding the holder concentric and that your collet or chuck is accurate. Inside the lathe tool setter electronic, we have two different circuits effectively. One is a circuit that is the self-contained circuit with a beeper and or an LED, if you prefer the quiet option. It has a switchable 3.5 mono socket, which is not used for the internal circuit. It has two little batteries inside the shank. You remove this little plug in the end to replace the batteries. They should last a very long time because they're just driving a LED and a little beeper. So I haven't actually run any of the batteries out on the products that I've been testing. Anyway, so there's that little self-contained circuit. Once you plug in a 3.5 switchable plug, it disconnects that circuit effectively and reroutes the circuit just through the contact points. And as mentioned, the contact points are the same material as the ITTP probe. But there's less of them because you've only got two sets of contact points, whereas the probe has in total 6 sets of contact points. So it should, although the probe is completely reliable anyway, this should be even more than completely reliable. Although, to be fair, I haven't got the facility to immerse the contact points in little reservoirs of fluid as per the probe, because it's going to be used in all different orientations, and so that just wouldn't be feasible. So there'll be, rather than a ITTP gel. There's just going to be some sort of electrical fluid on the contact points to keep oxidization off those. So it could be an oil-based or a silicon-based oil on the contact points. So once you plug in the 3.5 jack plug, it switches that circuit off and effectively reroutes it through just the contact points. So you have a simple passive circuit now, normally closed, circuit suitable for 5 volt approximately, low volt, low current switching through to a machine's control electrics and control software. I haven't got involved in that side of it. Hallmark don't have that set up at the moment on their NC lathes on Rapid Turn and Slant Pro. They may do in the future. I've been keeping the lines of communication open with them over this development project. But this may be something that some of you enthusiasts will want to set up that have a background in electronics and software. It's not something that I've been involved in. My background is tool making, but I understand enough about it to manufacture the instrument itself. So obviously the anvil surface, the X surface, has to represent exactly the center line of the lathe, X0. So it's really important that the anvil surface is on X0 so that you can set all the tools correctly. And one thing that was requested several times during the development phase by the followers of the development phase was to find a way to make the contact points and the resting position for X0 adjustable. And I could see the reasons for that. I had been thinking about it myself, but I couldn't see an easy way to do it. Make a good idea to have it adjustable because long-term adjustments might be required due to contact wear, due to damage, due to the wish to offset the position for some reason or another. And so it would be a lot more versatile, a lathe tool setter, if the contacts could be adjustable. So I eventually found a way, an internal design that allows to make the contacts and therefore the X position adjustable. But that's quite a lot of extra work to manufacture all those components in such a way that it is very reliable and predictable and easy to use. So it adds quite a bit to the cost of this lathe tool setter. So we have a little hole in the top cover plate, and you enter an Allen key into an adjusting screw which is spring biased, and you can make an adjustment very easily to move the anvil backwards and forwards by shifting one of the contact points. That makes it very versatile. Although Hallmark at the time of this video don't have Slant Pro or Rapid Turn set up for automatic tool offset setting using probing routines, I can simulate it by using the mill probing routines here. So I'll just put in the clip from the introduction video. I want to get as much information on the LTS-E as possible in this video. So you'll probably see a couple of short repeat clips from that introduction video. So let's just go through now a simulated probing routine as if it was set up as a lathe, roughly in that orientation with a boring bar and the LTS-E. So that's setting the, for example, the X, and we might set the Z this way. And you can see how that now works as a automatic lathe tool setter. So to some extent it is potentially future-proofed. I also want to make it clear that I offer this LTS-E as a self-contained tool setter with its own battery-powered circuit, but I don't want to get involved in the development of the software or the electrics on various different machines. There's a whole lot of different options there and things to test, and that's not my background. I'm better to stick at what I'm good at. If you're an enthusiast and you want to get involved in that, I'd be very interested to hear from you. but just be aware that I don't offer the service of the design and development of your machine's electrics and software compatibility for this lathe tool setter electronic. Right, well, let's cover some details in the machine itself. So I'm just setting it up in Slant Pro. One thing you'll notice, if you haven't already, with a lathe tool setter, is that it will expose whether or not your collet or chuck is holding your work or your tool setter concentric. As mentioned, this diameter here is part of the overall body. It's all machined out of one solid piece of steel, cylindrically ground between centers, so it's very accurately a straight parallel cylinder. And you can check to see whether or not it's holding your work and your tool setter parallel, whether your chuck and collet is accurate. And this is within about 1/100th of a millimeter at the moment, but it's very easy to have your 5C collet insert installed in correctly, or with a bit of dirt on it or a burr on it, and you'll find your 5C system is not concentric. And that's something you'll need to address if you want to do accurate work. Funnily enough, Rapid Turn doesn't have a 5C insert and is likely to be more accurate because the 5C collet installs directly into the spindle. So as per the introduction video, the first thing that you need to do when you set up the lathe tool setter is to dial in the flat surface of the anvil parallel with the x-axis and set the index plate bubble in the middle vial to the center. Once that's set, it's permanently set for this lathe. Every time you put it in, it's automatically able to be aligned in a few seconds. Now you could mark on there between the body and the index plate with a very fine felt pen a position, and if you had another lathe, another position. So one was a Slant Pro and one was a Rapid Turn or a manual center lathe, and you could then just adjust it into the two different positions so that your lathe tool setter would suit two different machines. But anyway, now I've got that set and I can go ahead and mount all the tools. As per the introduction video, the first stage is to mount all the tools, and it's very useful to have a flat anvil surface on the center line of the lathe to mount all the tools. Then we go in and set the tool offsets. Just regarding the index plate for setting the spindle rotational position, it's very easy to set the bubble in the middle between the lines of the little bubble vial. Now occasionally you might strike a position where the lathe has been sitting for a long time and there's a kink in the belt and it will tend to want to ride away all the time. Then you just need to rotate it around, for example a full turn, to get the kink somewhere else in the belt. But normally I find 9 times out of 10 there is not a kink present where I want to make the adjustment, and it's very simple and quick. It can adjust it quite accurately in a rotary position, in a rotational position, but usually it doesn't need to be that accurately set because your tools are on center anyway when you're setting the tool offsets, and so even if it was a couple of degrees out of position, it would still be perfectly accurate. Well, you've seen some examples of setting tool offsets in the introduction video, so let's give another couple of examples of tools that were not shown in that video. Let's do an example of a drill. So if we put the drill in its rotational position so the flutes are in line with the anvil face there rather than say there, it makes it a lot easier. Now we can just move the tool into position, come into contact, step in the last little bit, and at that point we enter the diameter of the tool into the tool touch facility. This is the only time when you're not setting X0 with a drill or something like that. In this case you'd be entering a minus value because we're forward of the center line. We'd enter minus 8.6. if we were coming at it the other way. So let's just do that. We'll turn it round the other way, set the vial in the middle, we're behind the center, and we'd be entering a plus value at that point of plus, or 8.6, the diameter of the drill. Well, let's put in the example of setting a parting tool. So switch the unit on, come down into contact. Once it touches, we're on X0. We just enter X0 at that point. For the Z, of course we don't have to be on a center line here. We're just entering a Z position. If you've watched the development videos, I touch on the subject that this is obviously a different Z position to your work. So what you do is you set all your tools to the Z position of the tool setter, so they're all together in a family, all related to each other and the same connected offsets. Then when you put your work in, for example your first tool, your facing tool, you take a cut on the end, or you index in 0.5 millimeter from the end, 20 thou in from the end, you decide that's going to be Z0, then you make that adjustment in the main DRO, the work offset DRO, change your DRO to Z0, and that effectively shifts the whole family of tools that you've set that are all connected together to this new Z offset position. So that means your tool setter can set all of the tool offsets in one position, and then it's relocated to the new position of your job, the end face of your work, by changing the DRO setting. There's a really easy way to set the anvil to X0, the anvil face to X0, or to check that it is still set on X0. And I hadn't thought of this before. I only recently thought of it. I had a long-winded way of doing it on the prototype videos. So what we do is get a dial indicator adjusted to 0 on the corners, because remember so it's sweeping into 0 there. Remember that the corners are ground concentric with the whole body. It's all one piece out of hardened and cylindrically ground steel between centers. So if we have the holder running true and we set a dial indicator on 0, we can measure that diameter across the corners with a micrometer. In this case, this one is 44.2 diameter across the corners, so the radius is 22.1. So all we need to do now is to rotate using the index plate into the middle there, set our software on 0. I'm just doing this, can't actually see it, but I'm just doing this, and then index in and check that measurement. So we would index in to that radius, or it's a diameter on the control software, isn't it, to 44.2, and you can see it's very slightly out. It's about 1.5 hundredths out. That's less than a thou out. So, oops, I'm just bumping it here, trying to avoid the dial indicator. So then we put an Allen key in that little adjustment screw, and we can adjust the contacts to exactly 0. So as simple as that, we have checked or adjusted that the anvil face is on X0, the center line of the machine. I haven't got into the control software side of setting your tool offsets in this video. I want to keep this video reasonably concise. If you're interested in that side of it, have a look in the development videos where I develop the prototype. I cover the control software for PathPilot in those videos. I'll put a link in the description below. Most of you will be familiar with this side of it anyway. Well, that's probably enough on the LTS-E. Please have a look at the other two companion videos for the LTS-M and the LTS-F, just in case they are a better fit for your requirements. If you have any questions to do with commercial matters such as price and availability, please don't ask those in the comments below the video. I want to keep the YouTube videos mainly on the subject of technical matters. It suits technical matters better. Commercial matters change over time and they need to be able to be edited. So in the description below you'll find a link to the Hallmark Design Limited website where there should be information on pricing and availability and so on. If it's not there yet, it will be soon. If it's not there yet, you can go to contact and send me an email and I can give you that information by email.